and welcome to another lesson in our Information Technology series on the Practical Assessment Task, or PAT. To complete your PAT, you'll be working according to 3 phases. We've already looked at phase 1 in previous lessons where we covered the problem statement and identifying the requirements. Now, we move on to phase 2, design the solution. Here, we will cover program specifications, algorithms, IPO tables, classes, objects and data flow, database design, and user interface design. In phase 2, we will be looking at the program. The designer must work out the details of every aspect of the program before starting to create files or write the program code. The better the design, the less work there will be during phase 3. So let's get started on our design document. By the end of this lesson, you should be able to explain the difference between program requirements and program specifications. List expected events for a given program scenario. Classify events according to the sequence they occur in. And break down general statements of events into component parts. Thabo is working very hard on his PAT. Let's find out how it's going. And how's it going?
Well, I've done the research and analysis and I've identified the requirements. So I reckon we're ready to start programming.
You're getting way ahead of yourself, Thabo. What's my golden rule?
If you fail to plan, you plan to fail.
Exactly. The sooner you start to write the program, the longer it will take to debug and get it working. Detailed planning is crucial. That's what phase 2 is all about. At the end of phase 2, you will have to produce a detailed design document that must cover all these things. So it's important to keep a record of everything you do. So I suggest that you use a different Word document for each of the sections. Here's an example. Keep the layout of the documents the same. And keep all the diagrams you draw up in separate files in the same folder. It will be easy to combine all these files, type section headings, add page numbers, and you'll have your design document.
What's the difference between program requirements and program specifications?
Okay. Say a teacher asks you to design a program to teach and test spelling. Who determines what the program must do?
The teacher's the client, so the teacher.
That's correct. We use the information the client gives us to determine what the user should be able to do with the program, better known as the program requirements and program specifications. So once you know what the client wants the user to do, you have to use that information to figure out what the program must do. You don't have to say how this will be done or which components will be used at this stage. Just make a list of program events.
Is that really necessary?
Let's look at your PAT. The IT teacher, in this case me, may not know what he wants the user to do, right? But say your client wasn't in IT. Would he know all the things you have to take into account when you design the software?
No way.
No. If he knew, he wouldn't need a programmer, would he? He could do it himself. The program requirements are general statements about what the user must be able to do with the program. Say your client asks for an educational program. What are the requirements?
Well, the user will have to be able to log on and play the game and be able to change the password if needed. That's what the having trouble signing in option is for.
What about the administrator?
The administrator must also be able to log on and access the learner's details, their scores. Oh, also the games, the database with all the info the games use.
Correct. These are all part of the program requirements. We use the program requirements to determine the program specifications. Program specifications is a specific description of all program events. Everything the program must be able to do. Ready to determine your PAT's program requirements and program specifications?
I wouldn't know where to start.
Ask yourself what activities the users will be involved in when they use the program. Then you list these activities as events without worrying about the detail. If you have two or more categories of user, for example, a player and administrator, list their events separately under category headings. List any events all users are involved in under a heading of General. Your program specifications headings will look something like this: Player, General, Administrator. Let's start with the player. What must the player be able to do? When a player opens a program, they're usually faced with a screen that asks them to do certain things. What are those things?
Register if they haven't played before. Otherwise, log on.
Correct. Once the player has logged on,
They choose a game and play the game.
good. We'll go into more detail about the game later. And then,
They can probably view the score and game history.
and when they're done,
They log off.
yes. What about the administrator? What must he be able to do?
Log on and work with the database.
We can expand on that later. What else?
Log off.
See any resemblance?
They both log on and log off.
That's right. Both the player and administrator open the program, so we can list it under General.
They also both close the program.
Now that you've listed some of the things your program should be able to do, you can start breaking down each activity into a series of events. Everything that is essential to make your program work becomes a separate event. Let's look at an example of a login screen or user interface.
User interface.
Every program has different screens. We call these screens the user interface or GUI because that's how the user interacts with the program. On this interface, the user is asked to select one of four options. They can choose to log in, register, find more information, or close the program. Now you have to ask yourself, what else needs to happen? What is essential for your program to work if they click on one of the buttons? What happens when a player registers, for example?
They get a username, type in a password.
Correct. And if the player selects find more information?
There'll probably be a screen with information about how to play and how the scoring works.
These are the events you need to list in your program specifications. So, your specifications will look something like this. General specifications, open program. This happens outside the program. Close program or exit program. Log off can be listed here if all users log off in the same way. Log on must be listed separately as players and administrators log on differently. Let's take a look at players' actions. The player must be able to register, log on, get more information, and log off. You do the same with every section of your program. Let's take a look at what the administrator would need. An administrator must be able to log on, so the password is checked. View all the player's play history that is stored, and log off. Now you must ask yourself what happens once the administrator has logged on.
He'll be taken to an admin screen.
Correct. Let's call it the admin task screen. What should the administrator be able to do here?
I think he must change stuff and add new information and work with the database.
Database maintenance is a very important part of any program. It's always wise to handle the admin tasks screen separately as it involves many events. Let's call it database maintenance. Here, the administrator should be able to delete records, add terms and definitions, view all players' gameplay history that is stored, query the database and produce reports, see game history of all users. Data from the user's text files will be displayed. And they must be able to log off or close the program. At this point, we only look at what the user should be able to do, not how the program must deal with the event. We'll deal with the program response later. What about the user interface or screen of the game itself?
That'll have lots of events. Depends what the game is about.
Think about your pet. What do you envision?
The player will be able to choose between the different games and different levels.
Is that all that will happen?
There's lots more. They'll start the game, choose an answer, get a hint if they pick the wrong answer. Oh, and they'll get a score.
Very good. You've mentioned quite a few events. Let's look at learnerlanguage.com for an example of a game. On the user interface, you have to choose a game, then a category. Then you start the game, choose an answer, and so on. Let's list the game specifications. On the user interface, you have to choose a game, then a category. Then you start the game, choose an answer, get a hint if the answer isn't correct, get a score, and exit the game.
So I literally only have to list all the things that can happen in the program.
Yes, list everything that happens in the program. Let's take a look at another example. Say a user goes on the internet to look up human-computer interaction, or HCI. Can you list some of the simple events or things that you will do? And remember, only tell me what will be done, not how it will be done.
Oh, I think I can do this. First, you'd open your browser program, like Internet Explorer or Mozilla Firefox. Then you'd open a search engine like Google and enter the keywords. Then you select one of the web addresses the search engine suggests.
Very good. Can you list a few things the search engine will have to do?
Check the keywords to find websites related to the topic.
Yes, what else?
It'll sort the websites it finds and will list them in the sorted order.
You're getting good at this. A few years back, an entire program ran in sequence from start to finish. Can you tell me what a sequence is?
Isn't it when something happens in a certain order?
From start to finish, yes. Events can be placed in any order within a program, but each event runs in sequence. A sequence runs from start to finish. In the past, before GUI interfaces with icons, windows, and a mouse, your entire program ran in sequence from start to finish. The only way a programmer could change the sequence was to specify that if a certain condition was met, the program had to jump forward or back to a different place in the sequence, or that one part of the sequence should be repeated a number of times. The user could press the pause key to stop the program for a while, or the escape key to stop the program altogether. Otherwise, the program just kept moving forward in the sequence until it ended. And imagine this, only one program could run at a time.
Ouch.
These days, program is event-driven. This means a user can choose any part of the program, in other words, different program events. We can jump around between different events in one program and even between different programs without any problems. The program doesn't have to run in sequence. What starts an event in a program?
The user must select an option.
How?
By clicking the mouse or pressing the enter key.
Good example. The user, if he clicks the mouse or presses enter. The system, like when a printer sends a signal that it's out of paper. Or by the program itself, like when the user's name cannot be found in the database. Although the user can trigger events in a different order, placing all the events of your program into sequence, the order you expect them to happen, gives structure when you design the program. It makes planning easier. Once you've listed the events of your program, you should break them down into component parts. Let's do another exercise. The screen below is for an educational game, Cetera, which teaches countries, capital cities, and flags of the world. Look at the buttons offering choices as well as the input components. Then, list the events that will take place during the use of the program.
Select the correct answer, time the test, show the score, see the high scores for this exercise. Exit the exercise.
Note that there is no Get Test Assessed event in this game if you select the correct answer. The background turns green. An incorrect answer gets a red background. The user clicks until the correct answer is shown, with the score being adjusted for each click. Remember not to focus on the player only. Pay special attention to the screens the administrator will use as well, like the database maintenance screen. What kind of events would you expect when working with the database? What do you store in your database?
User information, terms and definitions, and game information.
Yes. We usually use tables, queries, or reports in a database. These events should be listed like this: new user, new term and definition, new game level, or to delete, edit, or update a record. Here is an example of a new record being created for a user. If you make use of queries in your PAT, list them as events too. Queries. Select all players sorted alphabetically. Select players in one grade sorted alphabetically. Select all terms and definitions. Select terms in one of the levels. Select terms by category, for example, hardware. Select all players' names and top scores, or average scores. Select one player's record of games played including date, level, score. The same goes for reports. The events can look something like this. Print the list of terms and definitions for handouts. Print list of games played for one player. Print to screen the list of all players and top scores. Make sure you list every event of your program in sequence to make planning easier. It will also make reading the code easier. Here's your task for this lesson. Here is the user interface of a language game that asks you to match columns. You must match a word with its correct translation by using drag and drop. When you are done, you click the Continue button to check the answers and see your score. Name the events involved in playing this game in sequence.